Another series in the tornado series here. Marion, 21 years ago already.
And violent tornado, F-4
Yeah.
classification. So those two highest tiers on the tornado rating scale, F-4 and F-5. The worst of the worst, if you will. There haven't been too many in our state's history. 13 if you go back to 1950 when records started to be reliably kept. So 13 tornadoes, F4 or F5 in North Dakota history in more than 70 years of record-keeping history. And again, we've gone over some of these so far on this Morse Code of Weather Tornado History series, like the Fort Rice and Fargo F5 tornadoes, the Mott region and Elgin ones in the 1970s. There was also 5 in the 1950s. Again, that includes the Fort Rice and the Fargo ones, and then those 2, like we talked about, in Grant and Hettinger counties in the 1970s. And now some more recent ones, these violent tornadoes. There were 6 from 1999 to 2010, all in the eastern part of North Dakota, and the most recent one was in 2010. But let's go back to 2004 for the Marion F4 tornado, and we'll talk about some of these other ones in the coming weeks as we wrap up this tornado history series. But going back to Sunday, July 18th of 2004, 21 years ago this week, peak winds with this F4 tornado were between 207 and 260 miles per hour. That was on the old F scale before it went to the EF scale. Buildings were swept from foundations. That's how it got this F4 rating. It tracked for 12 miles through Barnes and Lemoore counties. No fatalities or injuries, thankfully, because the family at the farmstead that received the worst of the damage was not home at the time. Chauncey, who works at the Weather Service and was working at this event, says that they were out in their hay fields and actually saw the tornado. Now, the Newt farm that I'm talking about here was devastated. 2 homes, 20 grain silos, outbuildings, vehicles, and heavy machinery were all destroyed. A safe was ripped from basement and thrown several miles. A semi-truck loaded with grain was tossed 250 yards. 49 cattle were killed, and damage totaled $1.7 million. So Chauncey will explain the atmospheric setup that led to this violent tornado back in 2004.
On that particular day, there was extreme instability present. High temperatures were well into the 90s, and the dew points out in southeast North Dakota were in the 70s. It was very sticky air, and there was a weak frontal boundary that was progressing across the area. But in many ways, this was a subtle thunderstorm day. It wasn't necessarily anticipated that there would be a violent tornado that particular day. The ingredients all came together, but there was really uncertainty about whether or not that warm layer of air in the middle parts of the atmosphere, that capping inversion, was going to hold or not, or if thunderstorms would develop. The winds high up in the atmosphere at the jet stream level were out of the northwest and strengthening. So there was strong wind shear through a deep layer of the atmosphere that really kind of helped move that thunderstorm almost like a block of wood in a stream off to the south-southeast. The low-level wind shear also characterized that storm and helped the tornado itself to also move off to the south-southeast in this particular case. So if we look at all the tracks of our tornadoes historically, a lot of them do track to the east and the northeast, but there are ones in our records that head other directions, and that's why it's always important for folks to realize that there's not one dominant direction that you can always expect a tornado to move from. However, it is worth noting that the track in this particular F4 tornado is somewhat unusual. The tornado lifted just before it actually got to the community of Marion. In fact, the thunderstorm itself actually weakened very quickly after sunset. In this particular case, the really hot daytime temperatures that were in the 90s and those really high sticky dew points fueled the storm, but as soon as the sun set, that warm layer of mid-level air, that capping inversion, took back hold, the thunderstorm itself completely diminished pretty quickly after sunset. So a little bit of lucky timing for some communities that were further down in the path of this particular tornado.
So again, the town of Marion was very fortunate that it lifted just before it tracked to the south, just ahead of the town of Marion. Again, that unusual track from north-northwest to south-southeast. And it was one of 8 tornadoes that day, the strongest one for sure. The other tornadoes were rated F0 or F2. Chauncey will talk more about how this storm evolved on radar.
On that July day, a tornado watch was issued in advance as indications started occurring that, yes, storms were going to develop. And then the radar was able to detect supercell thunderstorms developing in eastern North Dakota. The one that ended up producing the F-4 violent tornado developed over Barnes County. You could see the rotation develop. Tornado warnings were issued at the time. Warnings were technically issued by county. So in today's world, all your viewers are likely used to seeing warnings that are drawn as polygons, really honing in on the threat area. In those days, the warnings were issued for entire counties. So the tornado warnings were issued in advance, and it described where it was, but all of Barnes County, all of Lemoore County were technically in the tornado warnings.
Again, fortunately, no injuries or fatalities despite that devastation at the farm in southwest Barnes County. Now, after the storm, there was a lot of research done to figure out what happened with this tornado and help us to warn you for future tornadoes.
This tornado actually led to quite a bit of research. There was multiple papers that were published on this particular event. The tornado itself was relatively high based, and there was a lot of research initially done that suggested that cloud bases needed to be relatively low for large, significant tornadoes to occur. This one was a large, dusty tornado with a high cloud base. We learned a lot from this event and this particular tornado that's helping us even today to better identify these kind of patterns that can lead to these tornadoes on these really hot, sticky days where maybe the cloud bases are a little high, but the wind shear compensates for it.
Another really interesting piece of research from this tornado case was that evapotranspiration, you might have heard it referred to as corn sweat, the moisture that is released by plants and crops adds humidity to the atmosphere, and the research showed that there was a lot of that happening in the northern plains at the time, contributing to the very high dew points on that July day when it's usually peak timing for these crops to be releasing a lot of moisture into the atmosphere. And with the higher dew points, that allowed for the initial thunderstorm formation, the updrafts, to overcome that cap or warm layer aloft. So really interesting research that came out of it, and interesting as I put all that together looking back 21 years ago.
It's amazing too. Your research and Chauncey's research,
Yes.
you know, and a lot of information going into that. Jacob, thank you so much.
You're welcome.